In this lecture, we look at the mathematical meaning of inverses, concentrating on function inverses. When we create an inverse function, we interchange inputs and outputs. In our graph in the plane, we interchange x and y, and so we swap the x-axis with the y-axis. We can swap the x-axis and y-axis by reflecting across the line y equals x. Here from Wikipedia is a picture displaying that effect. The graph of y equals f of x is in red, and after we swap a reflected across the dotted line where y equals x, we get the graph of y equals the inverse function in blue. In mathematics, the inverse of an operation is something that undoes or reverses the operation. If we're adding, then the inverse of 4 is minus 4. Minus 4 is called the additive inverse of 4. If we're multiplying, then multiplication by 4, the inverse of that is dividing by 4. So the inverse of 4 is 1/4. 1/4 is the multiplicative inverse of 4. If we're composing functions, then the inverse of f is the inverse function. These types of inverses are all different. Don't confuse them. The additive inverse of 4 is minus 4. The multiplicative inverse of 4 is 1/4. With functions, the inverse function is what we get under composition. We'll talk more now about what that means. If we compose f and f inverse, we get the function which doesn't change anything, merely maps x to x. This is called the identity function. For example, if f of x is x plus 4, then the function f adds 4 to the input x. The inverse function, x minus 4, subtracts 4 from the input. If we apply f and then g, we first add 4 to x and then subtract 4. In function notation, g composed with f is just x. G composed with f of x is equal to x. Let's verify by function composition that f of x equals the square root of x cubed plus 9 and g of x is the cube root of x squared minus 9 are inverse functions. We can do this by computing the composition g composed with f of x. That's g of the square root of x cubed plus 9, which is the cube root of the quantity square root of x cubed plus 9 all squared minus 9. Notice that on the inside we were squaring a square root. We can simplify that. We're also adding 9 and subtracting 9. We can simplify that. We're taking then the cube root of x cubed and we get x. If we take g composed with f of x, what we get out at the end is x. So g and f are undoing each other's operations and restoring us to the original input. G composed with f of x is x. We could instead compute f composed with g of x. That's f of the cube root of x squared minus 9, which is the square root of this mess, which after some simplification becomes x. Here we're going to assume that x is not negative, so that when we take the square root of x squared, we simply get x. So what we've just shown is that f composed with g of x is x. F and g in this problem are inverse functions because when we compose g with f or f with g, we return x to x. The composition of f and g in either order returns x to x, so f and g are inverse functions. They undo the operation. They reverse each other's operations. When does a function have an inverse? It turns out that there are two critical properties necessary for a function to be invertible. The function needs to be one-to-one and onto. In the next presentation, we explore one-to-one and onto functions.